All right, so again, like I said, the two ones in yellow are the ones we're going to focus on, but the top ones too, you might see. Okay, so let's see, where are we at? We finished on this one, H. This guy right here, H. Okay, so we got to find the derivative of that guy, natural log, and then of root. Well, we've done kind of one like this before. We've done, where is it? The natural log of a, not that one. Where is it? This guy right here. D from earlier, yesterday. This one's exactly the same as the other one, just instead of x, it's x squared plus something. We're going to treat it the same. We're going to treat it the same. So here we change the root to a power. That's what we're going to do next. So let me go back down to where the problem is. I'm going to change the root to a power. The root is this whole thing. Okay. So I'm going to rewrite it. So it's going to be the natural log of that guy to the 1/2 power. Okay. All right. Okay. So now we're going to follow along the steps. So when we're finding the derivative of a natural log, it says the derivative of the stuff goes on top, and then whatever the stuff is goes on the bottom. So that's what we're going to do. Okay. So first thing is I'm just going to put whatever the stuff is, x squared plus 2x to the 1/2. All right, that goes on the bottom. Its derivative goes on the top. Okay. So to find derivative of the stuff is right here. This is the stuff I'm talking about right here. Right, this stuff here. Okay, we've got to find derivative of that. Well, to do that, we're going to use chain rule. Okay. So we're going to move the 1/2 to the front. Subtract 1/2, or subtract the whole, I should say. And then I got to find the derivative of the inside. 2x plus 2. Okay, that's technically the derivative. But what I have to do now is kind of clean it up. There's one thing I can't have a fraction on top of a fraction, and I can't have a negative exponent. Those are the two things that I can't have. So let me clean it up. All right, so the things that are going to go, so let me highlight some stuff. So the things that are going to go on top on the numerator are this one and this guy here. Everything else, this guy, and this guy are going to go to the bottom. Well, one of them's already at the bottom. So at the bottom is going to be 2, and then I'm going to have x squared plus 2x 1/2, and then I'm going to have x squared plus 2x 1/2. Okay. And on top, the green stuff, I have a 1, but I don't need to write that because if you distribute a 1, you just get 1. You just get itself, I should say. Okay. Couple things here. First thing, these two guys have the same base, so I can add their exponents. So if I add 1/2 and 1/2, I get 1 whole. Okay, so I get 2x plus 2, 2 x squared plus 2x. Okay. And then I see a 2 on the bottom. You see this 2 here. It's by itself. It's a lone wolf. And I see that I can factor out a 2 here. So let's do that. Factors out those 2. So I get x plus 1 on top, x squared plus 2x on the bottom. Now on the bottom, I could factor something out too, right? An x. But would that cancel anything out on top? Like if I were to factor the bottom out, factor an x out, would that cancel out? Would it do anything cancel out here? No. So if that's the case, then you just leave it. You only factor when you need to. You only factor when something's going to cancel out. If something's going to cancel out, don't factor. The reason I factored up here was because I knew something would cancel out. I had a lone wolf 2 here, and I said, hey, I can factor out a 2 here. So if I factor out a 2, they cancel out. And that's why I did it. All right. Okay, so this guy's essentially the same thing. It's the same thing as the one we just did. The only difference is the stuff is a fraction. It's a division. Okay, so this would be, if I rewrite it, this would be natural log x squared minus 1, x squared plus 1 to the 1/2 power. Same steps, right? Same steps. The derivative of natural log, say, take the derivative of the stuff over the stuff. Okay. So this is the stuff that I'm finding natural log of. So I need to find the derivative of it on top. On bottom, it's just going to stay the same. Okay. To find the derivative of the stuff, I have to use chain rule first. So 1/2 to the front, rewrite what's inside parentheses, subtract a power, times. Now I have to find derivative of the inside, which is a division, quotient rule, right? So I got to use the quotient rule now. Okay. So low times the derivative of the high minus the high times the derivative of the low, all over the low squared. Okay. Let me move this, center this a little bit better. Okay. So calculus is done. There's no more calculus to be done. We found this is the derivative. But the chances of this being an A, B, C, D answer is very small because it needs to be cleaned up a little bit. First thing, distribute these guys. Okay. So I'm not going to touch the beginning first. There's a lot of things to do, but I'm not going to touch this guy first. So what I got to do is I got to go 2x cubed plus 2x minus 2x cubed minus 2x. Okay. And then the bottom stays the same. Plus 1. Uh-huh. Did you some? Let's see. Yes, you're right. Yes, you're right. I skipped that step. That's what it was. Something wasn't making sense to me. Thank you. So yeah, so there's a negative out here. So when I distribute this guy, that's going to be negative here. But then I distribute this guy, it's going to give me a negative, but then there's a negative already here. So that's actually going to make it a positive. Thank you. Yeah, that makes more sense because otherwise it was going to be 0. And that's not good because I skipped a step and I shouldn't have done that. Okay. All right. So this guy cancel out. Okay. So I have fractions on top of fractions on top of fractions. So I'm going to try to consolidate them to one fraction. Okay. So this guy here, the green, I'm going to move to the bottom. Okay. The green I'm going to move to the bottom. Everything else I'm going to leave on top. We're running low on room here. Here we go. Okay, so on top I have 1 times 4x, so that's just going to be 4x. On bottom I got a whole mess of stuff. I have a 2. I have a x squared minus 1 over x squared plus 1 to the 1/2. I have one that's already there. And then I have an x squared plus 1 squared that I needed to move down. Okay, that's where I'm at right now. So I see a couple things. I see that these two guys are the same exact base, so I can add their exponents. Okay. So I get 4x, y prime equals 4x, 2, and then I have x squared minus 1 over x squared plus 1 to the first power. So no more powers needed to rewrite. And then I have x squared plus 1 squared. Okay. I could distribute this 2 here. I could distribute the 2 here, but it's not necessary because of my next step. It's just going to make the next step a little more confusing. So I have two of these guys here. I have 2 of these guys, right? So I'm going to rewrite it. Well, one of them can cancel out with the one on the bottom over here. This guy can cancel out with that guy. When I do that, I get 4x over 2 x squared minus 1, x squared plus 1. And then this 4 I can cancel out with this 2. This changes to a 2. This changes to a 1. So I get 2x over x squared minus 1, x squared plus 1. Nothing else is going to factor out. So you're done. Okay. So again, just be careful because everything we did under here, under the red line, everything we did under the red line was in calculus. This is the only part of the calculus, finding the derivative. But we had to clean it up. We had to, take into account the negative exponents, distribute, combine like terms. That's all just algebra. Okay. So again, be careful with that when you're doing that. Okay. All right. Okay. So last two. Actually, you know what? I want to skip J. Let's go to K real quick. We'll come back to J, but I want to do K because K is the same type of problem, but looks different. I see how students go to this problem and they're like, I don't know what to do. Yeah, you do. You know exactly what to do. We've been doing this for a while. Find the equation of the tangent line. So when you see these words, equation of the tangent line, what do you need to do first? Find derivative. If we don't have it, we need it. Find y prime. We don't have it yet, so we need to find it. Okay, so let's find it. Okay, so this one's got parts. This guy right here, it's got, oops, probably shouldn't do the same color. It's got two parts to it, right? Two parts to it. So first thing, if we find the derivative of the yellow, they're not being multiplied together. 4x squared and the natural log of 2x squared minus 1, they're not being added together. They're not being multiplied together. So I don't have to use quotient or product rule. They're not being divided. They're being subtracted, right? So I can just take their derivatives. So the derivative of 4x squared is 8x, right? Now I have to find derivative of the purple. Okay. Well, we know that it's going to be a fraction. The derivative of the stuff in parentheses goes on top, 4x. The derivative, the whatever the stuff is, goes on the bottom. And that's it. These are actually a little nicer because you don't have to go any further, right? We have to find the equation of the line. So the equation of a line is this, right? I need a point and I need a slope. Well, I already have a point. My point's right here. Point's done. Now we need a slope. So how do I find the slope at 1, 4? How do I find the slope of the tangent line at 1, 4? Plug in x. X is 1. Everywhere I see an x. So y prime of 1. So I get 8 times 1, 4 times 1 over 2 times 1 squared minus 1. So I get 8 minus 4, 2 minus 1, 8 minus 4, which is 4. Done. Okay, that's the equation of the tangent line. Okay, all right, so let's go back to J real quick. We'll be done after J. So I put J on there because it looks ugly. It looks like something that's very intimidating, but it really isn't that bad. It really isn't. We've done ones that are way harder than this. So it's got 3 terms in it. This one, and this guy here. It's got 3 terms, right? They're all positive, but there's a plus in between them. So they're on their own. I can find the derivative of the green, find the derivative of the purple, find the derivative of the yellow. Do them separately. Okay? Let's start with the green. The green is E. The green is an exponential, E. Well, we have a formula for that. If you're finding derivative of anything with E, it repeats itself. First thing it does, repeats itself. and then you find the derivative of the power. Okay. So first thing I'm going to do is repeat it. F prime of x. Repeat it. Then you find the derivative of the power. Okay. Well, the power is tangent 3x. How am I going to find derivative of that? What am I going to use? Mm-hmm. So yeah, so I'm going to use that, but what rule am I going to use? Mm-hmm. Chain rule. Yeah, chain rule. I'm going to use chain rule, right? I'm going to find the derivative of the outside, and then I'm going to find the derivative of the inside. Okay? So the derivative of the outside, derivative of tangent, is secant squared. Okay. Derivative of the inside is just 3. Okay, that's the derivative of the green. Derivative of the pink. Well, I haven't done that one yet. I haven't done a 6 to the x power or 6 to anything power, but I have a rule for it. It's right here. 6 is a. U in this case will be x squared. 6 is a. X squared is u. So it says, okay, so write the natural log of a. So that's the natural log of 6. Rewrite it times the derivative of the power. Okay, so that's what we're going to do. So first thing is the natural log of a, which is 6, times, rewrite it, 6 to the x squared power. And then the last thing is the derivative of the power, 2x plus. Okay. Then the natural log. Anytime I'm finding derivative of the natural log, on top is the derivative of the stuff, on bottom is the stuff. So the stuff is secant squared, or secant of x. On top is the derivative of secant of x. What's the derivative of secant of x? Secant of x times tangent of x. What's going to cancel out there? Secant of x, yeah. Because it's multiplication on top. This guy's a lone, the bottom's a lone wolf, so I can just do that. Done. I'm going to clean it up a little bit. I'm going to move the 3 to the front. I'm going to move the 2x times 6x squared natural log of 6 there, and then plus tangent of x. It's not a lot of common denominators, or not common terms, because you have e to the powers, secants, tangents, 6 to the x squared. A lot of those aren't common terms, so we can't really do anything with them. So we're done. Okay. So yeah, so these guys here are interchangeable. So you can move any of these guys in here, change the order, right? Because it's all multiplication. Same thing here. These guys here are interchangeable because it's all multiplication. So within those colors, you can move them around. And it's plus. So technically I can move the pink first and the green second. Yeah, so you have a lot of leeway there, yeah. Because multiplication and addition are commutative. Order doesn't matter. Okay. All right, so what I gave you was, so only the circled ones you have to do. There's 20 circled problems, okay? The other ones you can do for practice if you want, but they're not required. The only ones that are required are the circled problems.